Imagine a world with no sun, no sunrise, no warmth, no light, just endless darkness stretching in every direction. At first, it sounds like the worst place for life in the universe. But what if it's actually one of the best? These are called rogue planets, worlds that don't orbit any star. Instead, they drift alone through interstellar space, completely detached from any solar system. And astronomers believe there could be an insane number of them, possibly up to 21 rogue planets for every single star in our galaxy. That means the universe might be filled with these lonely worlds. For a long time, scientists assumed they were completely dead, frozen, dark, and lifeless. But now that idea is starting to break, because these planets might not actually be alone, and they might not be cold either. Picture this: a rogue planet with a moon orbiting it, an exomoon. Even without a star, something strange happens. The moon gets pulled and stretched by the planet's gravity as it orbits. Over time, this constant squeezing creates internal friction, generating heat from the inside. This process is called tidal heating, and it's powerful. It's the same kind of energy that keeps moons like Jupiter's Io volcanically active. But in this case, it could do something even more important. It could keep water in a liquid state. And liquid water is one of the most important ingredients for life. So now we have a heat source. But that alone isn't enough. Because without a star, any heat would normally escape into space almost instantly. So the real challenge becomes, how do you trap that heat? Early theories suggested a thick carbon dioxide atmosphere could act like a blanket, holding in the heat. But there was a problem. Under extreme pressure, carbon dioxide doesn't stay stable. It condenses into liquid or even solid form. When that happens, the atmosphere collapses and the heat escapes anyway. So that idea didn't work. For a while, it looked like these worlds were still doomed to freeze. But then, scientists found something unexpected. The answer wasn't carbon dioxide, it was hydrogen. A thick hydrogen atmosphere behaves very differently. Under high pressure, hydrogen molecules interact in a way that allows them to absorb and trap infrared radiation, a process called collision-induced absorption. Basically, when hydrogen molecules get packed together, they become incredibly effective at holding on to heat. And the result is insane. According to new models, this kind of atmosphere could keep temperatures stable enough for liquid water, not for years, not for millions, but for up to 4.3 billion years. That's almost the age of Earth. Let that sink in. A moon floating in total darkness could stay warm enough for life for billions of years. No sun required. To test this, scientists used advanced simulation tools like Helios to model heat flow through atmospheres and GG-Chem to simulate the chemistry of these environments. These aren't guesses. They're detailed physical models. But even so, there are limitations. For example, the models don't yet fully include the effects of water vapor or how atmospheric layers mix over time. And they assume simplified gravity conditions that might not perfectly match real worlds, so this isn't a confirmed discovery. But it's a powerful possibility. And it completely changes how we think about life in the universe, because traditionally we've searched for life in one main place, the habitable zone around stars, where temperatures are just right for liquid water. But this research suggests something radical. You don't need a star at all. In fact, being far away from stars might actually be safer. Near stars, planets face constant threats, solar radiation, flares, and catastrophic events like supernovae. But in deep space, it's quiet, stable, undisturbed. The loneliest places in the universe might also be the most peaceful, and maybe the most habitable. Think about what that means. Life might not just exist around stars. It could be drifting silently between them, hidden on dark, invisible worlds we've barely even begun to detect. Entire ecosystems floating in the void. No sunlight, no day or night, just internal heat, thick atmospheres, and billions of years to evolve. It flips everything we thought we knew. Because maybe life doesn't need the universe's brightest places to begin. Maybe it thrives in the darkest ones. And if that's true, then the universe might be far more alive than we ever imagined.